Okay, the end of the last video, we had converted our state machine from being coupled directly to the events to instead being coupled to an event stream. And where that left us was that we were stuck with a user which can't be identified. This application only has a single user, and that user's in a particular state. And that's not that useful. Really, you want to be able to have at least two users. I thought rather than get myself ready, I'd record myself getting ready, and then as long as I don't say anything that's absolutely ridiculous, I can just use that as a video. What are we going to do? We're going to change our user so it has a property that identifies it. And we're going to convert our event stream to being an event store. And what we want is that when an application is trying to, what's multi-line comment in Python? I don't know. When the application wants an event stream, it needs to be able to find the stream. And the way I see this done is you have the thing and its ID as the stream name. So in this case, it would be user ID. So we can say, I know I'm dealing with a user. I know I'm dealing with user 7. I want all of the events for user 7. I can use all of those events to build my user and take some action. Let's check that the tests run. They do. Brilliant. They all break because, yeah, we didn't keep them working in the last video. All right, so let's see why we've got uncommitted changes. No, we don't. Those tests are already broken, so we don't care about them. That's commented out. This is very messy, isn't it? So what we've got here is our event store, so let's rename it. So now we have an event store, which isn't really an event store, and a user, which knows about the event store, an alerter, which is a mock, and lets us show the effect of subscribing to an event by type. Okay, well that was a almost entirely automatic change. Yeah, that's still fine. So we will need to know, should be a good, but let's not worry about. Okay, yeah. So I'm partly doing this to learn the bits of Python. Cool. So we're going to want to import UUID, and every time we create user, whoops, we're going to create a random UUID. That won't work because user isn't expecting it. So we can come up here. That needs renaming. I've been doing lots of JavaScript where you can do this kind of thing. I can say UUID4 there. And why is that better? That's better because I can now come into user. Imagine I had lots of other code that uses this. I can say user ID, which is UUID, which defaults to none. And the tests pass. So I didn't break the application. I'm not using that user ID. If I have to stop and come back to this work, all I've done is introduce some unused code. It's nicer to get this working with code that will compile, the tests will run. It's that a little bit harder to get yourself stuck in a hole. So we're now, not that none is necessarily a good default. Choose a good default in case if it's going to, if you're going to be merging into trunk consistently, maybe littering the place with nons and nulls isn't a great idea. But at least the code isn't broken, so I know that any failing tests that are introduced because of me changing the application, not just me messing the code up. So our user can store its user ID. It now knows who it is that it's supposed to be. That should run fail. Intriguing. Subscribe to all. I'm already subscribed to them. Okay. And in subscribe to all, what happens? We append a subscriber. When the event store receives a message, so it receives an event. If there are any subscribers for that event type, they get called, and then anyone who's subscribed to literally every event gets that event. Well, if you have a system with a high number of messages, subscribing to every event could easily be a big problem. So we don't want to subscribe to all. What we want to subscribe to is, I think that only breaks one of the tests. It breaks both of them. Okay, yeah. It does actually depend on that subscription. That's all right. So we don't want to subscribe to all in this world. That's just too much data going backwards and forwards. We want to subscribe to a stream, and self is the subscriber, and the stream name is going to be user dash self.user ID. Now, if we wanted to be clever, we could read the class name, but we're not going to be clever right now. Subscribe to a stream doesn't exist. So we've got self, we've got the first parameter, which is the stream name, which is a string, and we've got the second parameter, which is the subscriber. And right now that doesn't have a type, and this is void. So self.stream subscriptions. I'm going to assume that this is a dictionary. So we're going to say let's create it. So we're going to have an empty dictionary, so we have to check. We have to check if it's in there. Da, da, da. I want to say something like if stream name is not in that, then self.stream subscriptions stream name is an empty array. And then we want to say self.stream subscriptions.append, stream name dot append subscriber. So I'm getting ahead of the test that I've written, but this would allow more than one subscriber to a particular stream, I think. Now when we send, we can construct the stream name. No, we have to change send as well. So the event store isn't responsible for saying what stream name, string. So let's default that for now. Don't actually think it should be allowed to be empty like that. And we can say if string name, then for subscriber in self.stream subscriptions stream name or the empty list subscriber.send event. What's I'm happy with here? Dict object is not callable. Wrong. Dot get. Can only concatenate str, not UUID to str. Okay. So we can turn that into a string. And it's not actually calling that code. So presumably, where's my event store gone? It's probably safe without that because we've got the default. Does that fix it? No. Let's see. Yeah, the new constantly update Docker thing is good. Who knows? Let's see what I've misunderstood here. Let's just print that out. So I believe that we have a stream subscription and we have a user with a ID, and we have a particular object. So that would suggest that we're getting into one of the problems with not breaking the code by adding your parameter at the end is you have to remember to go and call it. So, hello, my dog's just come to join me. So, hello, Pooch. Okay, dog's back outside. So we have to reinflate in my brain what's happening here. So someone says to the user that a particular thing has happened, and self.eventstream.send user locked out. And in our test, we say eventstore.send a particular event. So our test now needs to know what the user's ID is. Let's not be asking the user for that. That's user ID. And then down here, we can say we're going to send that event, and we're sending that event onto user and user ID. Okay. But still not that. So let's think that through. We're sending the event into the event store, not into the user. Yes. Event store.send. We've already subscribed. User ID. We've already subscribed to user-user ID. We've already added our subscription. And so here we should be asking for stream name. Let's see what that is. Not non-type. Okay. Let's do this. It's default to unknown. So we've got some duplication in the test, and that's what's breaking. When we come down here, we need that. Yeah, and in here we need the same refactor. Yeah, boop, 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 boop. User ID, and then here we're going to send that one, and that's the only one. Okay, great. So maybe this is why people rehearse it before they record the video. So what happens now? Now, when we send an event to the event stream, every consumer of the event stream is now sending a stream name. So our approach of adding the parameter to the end of the parameter list with a default type kept the code safe until the tests were green. Now I can remove that and say, whenever you send an event to me, missing one, positional argument. Why does it think that's broken? Okay. So actually, when we send the user locked out, and so let's call that stream name, and we can send the stream name there. Self.stream name. Gee, that's one of the things I'm loving about Python. The magic is that there isn't magic. Other languages I've used, it will figure this out for you. Oh, you're referring to stream name, which is available as a field. I'll use the field, and then. But in Python, no, I have to be explicit. It's the field name. That's pretty cool. So that's green again. Okay, so I hadn't actually changed every location, but there you can see the tests went red, so I knew it was I'd done something wrong, not just because the tests are red the whole time that I'm making the change. The tests should have been green the whole time. So I know when they go red, I've made a mistake. So now, when you send a message to the event store, you have to say what stream you expect that message to apply to. Anyone that's subscribed to a particular event type gets notified of that. Anyone who's subscribed to every event gets notified of that. And anyone who's subscribed to the stream that's being written to gets notified of that. So don't know that we're still using subscribe to all. No, we're not. And I didn't like it from a performance perspective. So I didn't like it from a lack of clarity perspective. So we can get rid of that and it should still be green. Yeah, well. So now we have a event store that can handle more than one user, I believe. And we have a user that is aware. It's very tightly coupled to the event store. It has the event store, it knows how to create the stream name, but you can imagine ways that we could separate the responsibility of the user and the responsibility of reading and writing to the event store. Let's write a test to prove we can have more than one user. And because last time we ended up copying the entire test anyway, let's copy the entire test. So test can have more than one user. We're going to have user one, and this is the user one ID. We're going to have user 2 ID equals UUID. And we're going to have user 2 we've still got our alerter. We've got some events for user 1, and user 1 isn't locked. Let's user 1 isn't locked. I'm going to come down here. We can do the same for user 2. And login failed. And we can assert that user 2 state is locked. We can assert that user 1 state is not locked. I was dead confident with the last change and it didn't work. So we've got some red further up the page here. These massive tests aren't helping me at all, are they? Do as I say, not as I do. Okay, so yeah, we can have 2 users. We've got lots of repeated setup here. You know, we could, IntelliJ might even be clever enough to do this for us. We can have write to stream, and yes, yeah, we can replace that. Maybe static, okay. So event store and user 1 ID. But what we can do here is we can say why not? We should be able to turn that into a parameter to a method. Surprising. Stream name, I want to pass in user 1 ID is a UID, stream name is a string, event store is an event store. I'm going to take that, I'm going to say stream name, we're going to get told of all the places it's broken. I'm going to pass that in there. That's the user ID. Self.write to stream. Yeah, I'm going to have the same here, and it's going to be user ID. Let's just review these tests now. We don't have that block, but we do have this block. Yeah, so we can take this and before we do that, let's come back to our method. Here you can see we don't use that anymore. Remove the parameter and lines. But these events are what we're going to vary. These are the events. It's to apply because otherwise the name will clash. Yeah, but I didn't want to do it like that. Let's rename this ease. And then we can make it a parameter. No, we can make it a parameter. Events. And then is it now telling me replace mutable default argument? No, none of this. Deary me. What I wanted was for the IDE to push these parameters up, but never mind. Okay, great. Now we can find the other places we're writing to the stream. Well, actually, that's one of them. So we're sending a single login failed. Whoa there. We're sending a single login failed event store user ID. Now here it's these. And we're still green. Right stream. Okay, same here. Nope. With let's go to fourth. Login failed to user 2. So this is why I was hoping the IDE would be clever enough to pull those parameters up for me, and then it could have done all that replacement. So now it didn't remove many lines of code, but it's all in one place now. Arguably, you could move this up. You know, we've got a method there on the event store to write a single event to a stream. You know, maybe we let it take more than one, but I might be getting overexcited for now. That's probably telling me it's got too many blank lines. Yeah. Duplicate code fragment. I don't think it is. Is it because it's down there? Let's see. Oh, I should say thank you to these nice people. Def setup. Yeah, okay. We're going to have self dot store equals a new event store, and see we because we're creating a random GUID each time we run the tests, I don't have to care about any clash from creating the event store. Let's just oops, to find all the places that's in the file, and self.event store there, and there, and there, and there. And you can see we're having to replace it in lots of places. Ooh, still broken. Object has no attribute, event store. Oh, that's upsetting, isn't it? Set up with an uppercase U works. Set up with a lowercase u doesn't work, even though set up is a word. Set up like that. No, oh, that's upsetting. That feels, well, we fell into that hole. That feels broken. Now, I'm going to move this up to the top. I want to see it first, so we can see what's not a test. You could move it to the bottom for the same reason. Could be static, eh? It can, but actually we could take the event store. If we say self.eventStore there, and then we can remove that parameter. That should still be green. All right. And we've got a user 1 and a user 2. I'm always torn with how much setup to lift out of the individual tests and how much to leave in the tests. I think the fact that we have an alerter is common amongst all the tests. Although what it's subscribed to isn't. Okay, we're now going off the rails a little bit. I can't see how to make it clearer. I am uncertain that it's very clear, but the video is not about what Paul thinks a test should look like. The video is about how do we turn this event store into an event store. And we have. We've got the ability to subscribe to event types. We've got the ability to subscribe to everything, which actually we've removed. Yeah, and we've got the ability to subscribe to known streams. Now, this is still a bit upsetting because we've got two different sets of subscribers. Now, what we could do is we could say, if you want to subscribe to a type, subscribe to a type, if you gave me the string of the event type, the signature is the same here. So if we have it's a stream that an outsider can't write to. which is known, I think, as a projection. Event sourcing projection. And I'm running out of battery. All right, I'll read this properly afterwards and check I'm not lying, but the way I think about projections are events are being written to streams, and a projection is a way to take what we know and show it in another form. So in this case, we would have a stream per event type. Whenever a new event type is written to the store, a stream is created specifically for that event type, and whenever an event of that type is written to any stream, it's available in that stream. That would be complicated to actually build, but here what we're saying is that I want to collapse to one set of subscribers. So let's break our code. I'm going to say the event type is a string. I no longer have to stringify that in there, and I can write that to stream subscriptions. And that's not particularly safe code, so I can just delete it. It's not safe because it's not doing this check. It's not saying if we've not already got a subscription, create an empty subscription for it. That will break our tests. Everywhere that we've got this in this file, we can have subscribe to a stream. Oops. I think, no, expected not to have been called once. Oops, wrong file. Subscribe to a stream, user locked out. I didn't change the code. That's so here we've got our event type is a string of the type of the event. So stream subscriptions get. Feels like really that should be after the so here we've got user locked out. But then we've got this. So we're sending an event, and I need to get this. Okay, cool. And that goes there. So we're not really writing to a projection, but we are emitting to our subscribers as if we're writing to a projection. So when I write an event to a stream, also fake that I have a stream whose name is the event type. Now we only have one way to subscribe. The name of that doesn't make much sense anymore. We can just call it subscribe. What's it I'm unhappy about? Yeah, that's fine, that's fine, that's fine. Let's run the tests again. They're still green. Cool. So now our event store has stream subscriptions, and subscribers can choose stream names. By contract, they know that event type is a projection, and whenever an event is written to a stream, we also emit an event on the projection. Now, you can't read the stream in this world. I can't find out about events that happen before I was created. So we now have named streams, but we're not an event store because it's not storing the events. I guess it's a message bus at the moment. Actually, you know what? What we're going to hit really quickly is I need to be able to read a particular event, and I'm going to be able to read forwards or backwards from that event. So I'm going to stop there, and I'm going to leave a note for myself that the next thing to do is to store the events and to let a client be able to read forwards from an event. To read backwards from an event, and to specify the expected next event. Why do you want to be able to do that? I want to be able to say what happened after a particular point in time. You've just told me about a user that was locked out because of malicious activity. I can subscribe to user locked out events. Now I want to take that user locked out event, it lets me identify that user, and I can see what's happened afterwards. If I see that there was money transferred out of a user's account, maybe something malicious is going on. I want to be able to read backwards from an event. You've told me that a user's locked out, what caused them to be locked out. And for safety, I might want to be able to specify the expected next event. So I read a user stream, and with that information, I can say the user is on event 7. There have been 7 events in the user stream. I've determined that the user's locked out, and I'm writing an event back into their stream. And I think that's event 8. And now the event store can say, well, actually, someone else has written 2 events to this stream since you read it. So you would be event 10 and give you the opportunity to decide whether you care. But that's a lot of waffle in one go. So we'll stop there. I hope that's interesting. I think this is one of the most cool ways of making software. It's not a golden hammer. We don't do it for everything, but I think it's a really cool approach to know about, and hopefully that's helped make some of it clear.